Okay, so let's talk about scientific notation. So what is scientific notation? Scientific notation is a notation for representing extreme large or small numbers in the form of a to the 10 to the nth power, where a has to be between 1 to 10, and n is the number of the decimal places from the right to the left. We move up to a. So here's a few notes regarding the scientific notation. N is the way that we converted between scientific and standard notation and represents the number of times that we multiply by tens. Remember, it's multiplied by tens. And we decided which direction to move the decimal, left or to the right. Remembering that in standard notation, positive exponent are number greater than 10 and negative exponent are number less than 1. So, a couple things you need to know. A has to be between 1 to 10. If it's no, you still need to keep converting to the right appropriate scientific notation. And this whole number, if n is a positive number, means this whole number is going to be greater than 10. If n is a negative number, the whole number is going to be less than 1. Okay, so there's two cases. If we move the decimal to the left with the number in the standard notation, then n will be positive. If we move the decimal to the right with a number in the standard notation, then n will be negative. So here, you try to convert it 8,150,000 to a scientific notation. So now let's see how do we move it. So this is your decimal. We move it from the right to the left. 1, 2, 3, 4, 5, 6. We want to move it here because the number a, whatever coefficient it has to be in between 1 to 10. So that means we have 8.15 to 10 to the how many power. It determined by how many places we move the decimal. Let's count it again. 1, 2, 3, 4, 5, 6. So since it's moving to the left, so this is going to be a positive number. This is equivalent to 8.15 times 10 to the 6th power. Another example is that we try to convert this number to a scientific notation. So now we move the decimal from the left to the right. That means the exponent is going to be a negative. So let's count it. 1, 2, 3, 4, 5, 6. We stop here. So we have 2.45 times 2 to the negative 6. Got it? So why we can't keep moving it? So because if we keep moving it, what we will attain something like 224.5. Our decimal is between 4 to 5, 10 to the negative 7 power. But remember the rule is this has to be in between 1 to 10. So that means this one is greater than 10. So that's why we don't use that one. We take that one that we firstly attained. Okay. So now is the opposite. How do we convert a number from scientific notations to a standard notation? So if you converted a number from a scientific notation of the form of a to the 10 to the n, it's the opposite. If n is a positive number, this means the original number was greater than 10. We move the decimal to the right n times. If the n is a negative number, this means the original number was less than 1. Then we move the decimal to the left n times. So here we have 5.23. Usually what I do is, since this n is greater than, is a positive number, that means this is going to be a number greater than 10. That means it's going to have a lot of zero. Usually I will put all the zeros as much as I need and before I move in it. Okay, So now I move the decimal. Since this is a positive number, I need to move it to the right 5 times. 1, 2, 3, 4, 5 in here. So that means I don't need this 0 anymore. So I have 523,000. This is the standard form of that number. Okay, so similar to here, we have 4.25 times 10 to the negative 4. So we know that this is going to be a negative number. This is a negative exponent. So that means we're going to move the decimal to the left. That means this number in a standard form is going to be less than 1. So what I would do is I put as much 0 as possible. I mean, you don't need to put that much. Depends on how big that exponent it is. And then I start moving it. I move it 1, 2, 3, 4. So to here. So that means I don't need this to 0. So this is going to be 0.00425. This is the standard form. Okay, for the multiply and divide the number in scientific notation. So here's the steps. You rewrite the factors as multiplying or dividing a values, then multiply or dividing a to the 10th value. The second step is you multiply or divide the a values and apply the product or quotient rule of the exponent to add or subtract the exponent and on the base and tens respectively. Be sure that result in the scientific notation. If not, then rewrite it in a scientific notation. Okay, multiply and write your answer in scientific notation. So basically you merge the like terms and you see the term that without the exponent, you merge them together and you merge the term with exponent. So I have 3.4 times 2.7. I would group them. And now we have 10 to the 5th power times 10 to the negative 2 power. Okay, 3.4 times 2.7. I have 9.18. And then 10 to the, this is multiplication by the product root of exponent. We have 5 at negative 2. So we write it, I have 9.18 times 10 to the 3 power. So now we need to check, do we need to rewrite it into a appropriate scientific notation? The first thing we check is here. Oops. The a, the coefficient, this 1. The a, is it in between 0 to 10? It is, so that means we don't need to do anything. Okay, so in here is the same. We can divide the number first. We have 5.32 divided by 1.9, and then 10 to the 4th over 10 to the negative 3. Okay, I'm going to use a calculator. So for the numbers, it's equals to 2.8. So for the tens, we have what? By the quotient rule, we have 4 subtract negative 3. Remember, this is subtracting negative 3. So that means this is equals to a positive number. And again, the 2.8 is between 1 to 10. That means we're good. Okay, now in here, multiply and we write the answer into a scientific form. Again, numbers, we multiply them together. And then the exponents, we multiply the exponents together. So for the numbers, we have 6.7 times 5.2, which is equal to 13.84 times 10 to the negative 3 at negative 6 at negative 3. So we have 134.84 times 10 to the negative 9. Again, in a scientific notation, we can keep the negative into the exponent. But when we talked about simplifying, then you can have the negative in exponent. But this is not simplifying, this is scientific notation. But however, this one is not appropriate because we wanted to keep it in between 1 to 10. What we want to do is we want to move the decimal to the right. So that means we have 3.484 times 10 because we move it 1 places. So there's 1 times 10 to the negative 9. So now we do this again. We have 1 plus negative 9 with negative 8. So basically, we would write 134.84 as 3.48 times 10 to the 1 power. We want to write this into an exponential form. And merge the tens together again. Similarly to this one, you want to divide the number together. And then multiply the exponents. So 2.352 divided by 8.4. So this is 0.28 times negative 6 minus negative 2. We have negative 2.8 times 10 to the negative 4 because that equivalent to add 2. Again, so this is less than 1. We want to rewrite negative 2.8 into a scientific notation. So we move the decimal to the right. So that means this is going to be a negative 1. Okay, so I have 2.8 times negative 10 to the negative 1 times 10 to the negative 4. So this is equivalent to 10 to the negative 5. So that's it for today. Let me know if you have any more questions about scientific notations. See you next time.